those numbers have to do with antigens. They're like capsule and flagellar antigens. That's where that 015787 comes from. And that is just really the most common one. This next organism, Salmonella, everybody has heard about Salmonella. I think we've referred to it a number of times in here. I think mostly people hear about Salmonella in relation to, say, Thanksgiving, because that's when they always bring up things about food storage and such. The thing about Salmonella, though, is that even though it's a common foodborne illness, very common, unfortunately, it is killed off by proper cooking. So people really shouldn't be getting Salmonella from food unless it's contaminated after the fact, or in something like, remember last time we talked a lot about like cross-contamination? And this kind of maybe came up about like taking the plastic wrapper off of the turkey. Something that's really a challenge when it's like shrink wrap, like stuck to it with really heavy plastic, and you're trying to pull it off and little splatters are coming off and landing on things. Otherwise, you kill off the organism when you cook it. So when they come up and they talk about Salmonella at Thanksgiving, nobody should be getting Salmonella from their turkey. If they are, it's because the turkey wasn't cooked properly. So you know how sometimes they say like, oh, after you eat your Thanksgiving dinner, you should put the turkey away right away, don't leave it sitting out all day or whatever. Could you get Salmonella from your turkey sitting out all day? What was that? Right, if you killed off the Salmonella, there's no way to get Salmonella if your turkey has been sitting out all day. You might get staph food poisoning because if people were handling it and it got exposed to staph and then the organism started to grow. But you can't get Salmonella from a properly cooked turkey, no matter how many hours it sits out. It can sit out for 2 or 3 days. You're never going to get Salmonella from it. You might get other things. You might get staph food poisoning, but you shouldn't get anything else. So it's killed off by cooking. There's something like 1.3 million cases of Salmonella every year in the U.S. 1.3 million. 1 million of those are from foodborne Salmonella. So how could that happen? How could it be so prevalent like that if people really are cooking things properly? Because most of the time, things are cooked properly when it comes to poultry. It's common in poultry, but you can get it in other things too. Right? Who eats like rare chicken? Nobody, right? We just don't even like that. So how do all those cases occur then from food? Right, or that cross-contamination thing. Using something, eating something that's not cooked, but it's been contaminated by something that's raw. So that when we say about the raw, contaminating cooked things, or contaminating things that were already cooked or things that you're going to eat raw, that is a huge, important reason that people get sick. So I know it sounds like, I admit to being paranoid about that. But there is a good reason to be paranoid about that. So just keep that in mind too. It is really important to understand about the foodborne illnesses, and we'll have a little, like half of a lecture talking about some of this stuff in a different way than this, like talking specifically about foodborne infections versus foodborne intoxications and the onset time of these things. And that becomes important because it helps prevent additional illnesses. If you understand, like for instance with Salmonella, it takes 24 to 48 hours, it might even take 72 hours before you come down with symptoms. So typically somebody will eat something, later that night they're sick, and what do they think? Oh my gosh, at dinner I had such and such thing, I got Salmonella, I got food poisoning. People say it all the time, I got food poisoning from something I ate last night. If you really get true, a true food poisoning, which is Staphylococcus. That means that Staphylococcus, it produced a toxin and you ingested the toxin. And so you're going to have an onset time that's quicker. But for something like Salmonella, it's a foodborne infection. It takes time for the organism to grow. It takes an infective dose. And then it's just going to be time before symptoms occur because the organism has to grow enough to cause those symptoms. So you have to think, if somebody actually really did have Salmonella, you're going to be thinking, what did they eat yesterday, the day before yesterday, and the day before that? So it's not normally the thing that you just ate if you're having those types of symptoms that are associated with something like Salmonella. Salmonella, usually the symptoms are going to be more like lower intestinal symptoms. So when we talk about upper, GI system symptoms, that's things like vomiting. Because it's like in your stomach, you're vomiting. That's what happens with something like staph food poisoning, even though you have lower intestinal symptoms too. But with these other infections, because it's been, a day or 2 or 3, the organisms are growing in your intestines. That's when you get cramping, diarrhea, that kind of thing versus vomiting. So you can get vomiting with anything. You can get other lower intestinal symptoms with anything, but it's just they're more primarily those, upper versus lower, and it's usually tied into onset times. And when you see those onset times, that helps people go back when they're investigating this and prevent other people from eating those foods and other people from becoming sick from them. So you see here, greater than 2,000 Salmonella serobars. Okay, so that means that those are like strains or subspecies. So there's all different ones. Mostly Salmonella is a high-dose organism, but there are some strains that are low dose. Low dose meaning you don't have to get an exposure of very many of the organisms in order to come down with the infection. You see you're transmitted to humans by contaminated foods such as beef products. So we think mostly of poultry, but meat also, because it's an intestinal organism, egg products, and water. And it would be milk in here too if it wasn't that we pasteurize most of our milk. So it's an intestinal organism, so it can get on any kind of animal. Typhoid fever. Typhoid fever is something that used to be a lot more common. It's something that does happen all over the world more frequently than here. I think here, typhoid fever, how many cases did we have last year? About 400, between 400 and 500 cases. It's not anywhere near as common as Salmonella, the foodborne illness, Salmonella. People, when they're traveling, get vaccinated for typhoid fever, so that has really reduced the rates quite a bit. I think what's worth mentioning here is just sort of the idea of Typhoid Mary. We brought up that story earlier in the semester, didn't we? Typhoid Mary. Because she was the one, the cook, that just continued to cook and everything. So, I mean, other than that, I'm not asking you to know specifically about typhoid fever for this. Again, it's like you're getting a lot of organisms, so because this one is really less of an issue these days, I'm not going to put that in there, but it is kind of fun to know. Oh, there it is, typhoid. Shigella, this organism here. Shigella, there are different species of Shigella. There are 4 species, so we'll leave it just as Shigella. Shigella is an important intestinal organism also. Shigella is, again, where that Shiga-like toxin came from, because the toxin associated with Shigella is an invasive toxin. Anything that's invasive, remember with the Intaviva histolytica, invasive, meaning it invades into tissues and such. The type of toxin that's associated with Shigella is the type that causes bloody diarrhea. It's the type that causes damage to tissues, and so that's one of the symptoms that you see with something like Shigella or a Shigella-like toxin. Shigella, about 15,000 cases per year in the U.S. Says that most of the cases are associated with young children, and lots of them are associated with daycare outbreaks. Just because, again, with children, their hygiene, no matter how hard they try, their hygiene just cannot be really as good as it really needs to be. So that's just always a problem, especially when children are not aware, you know, they're not going to be aware of like how hard it is to clean under their fingernails and to make sure that like if they wipe and they're just like learning and they don't have good coordination when it comes to wiping themselves after going to the bathroom and then washing their hands and not touching everything. So it's just unfortunate when you get a lot of kids together in like a daycare situation. It's easier for them to pass something on to another kid, and then they go home and pass it on to their parents and such. But other than that, I mean, it's like any other fecal oral organism. You know, if somebody is carrying it, it can be passed on to other people, or you can pick it up in the same ways that you would pick up any other kind of fecal organism. So here's that Shiga toxin. Here too, also the idea of leading to kidney failure. One thing that's interesting about Shigella is that there have been some cases in which the organism was resistant to every known antibiotic. So I don't know if at one time I mentioned that the scare is that we're going to end up at the point in which, in order to get an antibiotic, you have to give a stool specimen, and then they have to evaluate what is the antibiotic resistance of your normal flora. Okay, so remember with transformation, conjugation, if your normal flora of the normal organisms that are living in your intestines are carrying resistance genes, those can be passed on to an invading pathogen. So we don't want to get to that point. You don't want to get to a point in which it would slow down being able to get an antibiotic, plus like I'm pretty sure nobody really wants to have to do that anyway. But we don't want to get to the point where we're overusing antibiotics to the point that we have some kind of scary organism in which there's nothing to treat it with. So really at this point, we've been a number of years without discovering any new antibiotics. Right now, they're still just taking the antibiotics that we have and alternating, or not alternating, but altering them in a way so that they're going to be more effective. So, you know, right now, again, it's just something to be aware of. And really, it's probably been years already since they discovered these cases in which they were all resistant. So it's not anywhere near as common as something like the MRSA, the methicillin-resistant Staphylococcus aureus, but we wouldn't want an organism like this to end up in that same area. Because as it was with that organism, it was just something like 10 years ago that they had, you know, the first cases of those that were showing up in the emergency rooms rather than, you know, just showing up in the hospital. Now it's the #1 case of all of the serious types of, you know, skin infections. So like once things get started, you know, there's that lag period, but then it takes off. So Shigella, I want you to know, just because it's an important organism, it's important because of the type of toxin that it produces. And then again, it is something that is a fecal oral organism. Yersinia pestis is the next one. Yersinia pestis, like I can't ask you, oh, what is this cause? Because it says right up at the top that it's associated with the plague. But, and I know somebody did a paper on the plague, right? Did their paper? Right? Mm-hmm. So I don't know really how many people are familiar with the plague, because you know the Black Death, that idea that yes, like millions of people died in Europe from the Black Plague. It's very, very interesting if you ever get an opportunity to watch any of the shows they have, like on Discovery and National Geographic. There's a couple of shows in which they take people's diaries from back then and they sort of recreate what it actually was like for people, like to be in a situation where literally in some villages they lost 60, 75% of the population. So first you live someplace where you had all your relatives and friends and have lived there your whole life, and then now it's down to a handful of people left. Really, really interesting, because in some areas it killed off that many people. Also, what's very interesting about it is that since it killed off so many people, the question then was, why were some people left, you know, unharmed? Some people did recover, not that many people recovered, but some people didn't get it at all. Have any of you ever heard about this and its relation to AIDS? You have? Because basically there was a doctor whose brother, I think, passed away from HIV, and he was interested in knowing, you know, what is there a connection with some people that get HIV that never come down with AIDS? And they seem to be okay, even though sometimes they take a medication and they weren't really sure whether that medication actually prevented them, you know, whether it was that effective, but some people just like never end up getting sick. And so they went back and they, you know, dug up bones and went through everything, and then first had to just verify that, yes, Yersinia pestis was the organism that caused the Black Death. And then they found out that the people that survived it actually had a gene mutation. And it turns out to be the exact same gene mutation that prevents people who get HIV from actually coming down with AIDS. So really, really interesting, you know, coming up with that. And there is, like, again, one of those specials that you can watch on one of those shows. Like, if you're ever, like, searching through those things about the plague, watch those couple of shows that are out there. It's really fascinating how they went through. But that's just an amazing, you know, thing to discover, because they don't know really. I know that there's a lot of research going into this as to how they can use that information to prevent people from getting sick. Like, what can they do capitalizing on that kind of information? But really, really interesting. Just because I think it was so many people, you know, that are dying from AIDS, so many people that died from the Black Death, just wondering, just, you know, straight wondering if there was any kind of correlation with those, and finding out there was, I think, was really interesting. And then lastly, what's particularly interesting about this particular organism is that the plague is endemic here, like here in California. It's kind of over the western U.S., but the plague is endemic right here, right in our area. So even though it's rare when we hear about somebody getting it, it's more often that people have picked it up in Northern California than Southern California. There's only about 10 cases per year. Because basically the organism is carried by that Cynospora chaedophis. I think you guys have looked at that organism. It's a flea, the oriental rat flea, in your 107 class. And so it's carried by rodents. basically in cities, you would have an overcrowding of rodents, so the fleas would get passed from person to person. When fleas died off, they would then go on to a warm body, which would be a human, and that's how it gets passed to humans. But today, mostly in our areas, the rodent populations are controlled. But when you go to national parks and you see all those signs that say don't feed the squirrels, don't feed the chipmunks and such, that is part of the reason. Is because you don't want to have a huge overpopulation of rodents anywhere, because they do find that there are animals out there that will be carriers. So then once you get an overpopulation, then it spreads from animal to animal, and then it's much more likely to get on a person. Normally, the cases that occur right now happen because somebody takes their animal into one of the parks, your dog or such, goes up to a dead animal. The dead animal has the fleas on it. Where do the fleas go when they're on a dead animal and a nice warm animal comes up to it? Right? The fleas jump off the dead animal, they're attracted to the warm animal, which could be you if you were the one handling a dead rodent, especially.
Is the plague deadly?
It's treatable. It's treatable. So it's not usually going to be something that's going to be fatal. However, if the bubonic plague, it's called, gets changed into the pneumonic plague, like if somebody is infected with bubonic plague, it's still this organism, Yersinia pestis, but it goes into pneumonic plague, then it's in their lungs, then it's transmissible person to person, and that's what makes it more of a scary thing. So basically, like there have been a couple movies out which show something like somebody's at the national park and they're feeding a chipmunk, and then later, the next day or something, they're kind of sick, they're like, having a fever or whatever, but they have to fly home to New York. So they're on a plane, they're coughing, they get to New York, they take the cab, they're coughing, they get home, they end up dying. It turns out that they have, bubonic plague or pneumonic plague. But in the meantime, they've now passed it on to everybody on the airplane, the cab, the people in their apartment building, and so on. And so it kind of comes up with that scenario, almost like, the movie Contagion or something, where it goes through how these things can happen. That's actually something that could happen like that. It would be treatable and everybody would be okay, just a lot of people would end up getting sick with it because it can't go into pneumonic plague, early on. If it stays in bubonic plague, then it's not transmissible person to person.
What's the factor that turns it from bubonic to pneumonic? Is it time or?
I don't know if there is a certain time factor in there, but it's not necessarily a long time. Did you come across that?
They said, they were really vague about it. They said if it was left untreated, that was it. Or either that, or they were talking about how in the old times they didn't have any treatment, so it would just lead to pneumonic because of no treatment, or it takes too long, and when they get the treatment, it doesn't work.
But it's not 100%.
Yeah, it's rare that it'll work. That's what they said.
It's rare that what?
Like the antibiotics would work. It depends on what stage. Like they said, it's really big because it's really hard to control. That's what I read.
Once it's in.
Mm-hmm.
But I don't think it 100% will go into pneumonic plague, right? I don't in other words, I think it's not completely understood why with some people it would go right into pneumonic plague. It could have to do with their immunity also, but that's just guess on my part. So another reason why we've kind of had a call of it here because our squirrels here. So did anybody ever hear about what happened on our campus with this? Because, and also this should go for all of you, if you find that an animal like on your property that looks like it died, but it's not obvious what it is, you know you're supposed to call the health department, right? Because like things like when you find like a dead bird, like one of those big birds or something that like might be carrying like West Nile virus or something. So if it doesn't look like they died of something like they were, you know, run over by a car or something. So if you find a squirrel that's just dead and it doesn't like look like it's apparent that something happened to it, you're supposed to call the health department. They come and get it, they check it for the plague or for West Nile or for, you know, something. And so the school, I don't know how many years ago now, I want to say like 10 years ago now, but the squirrels used to be really bad. Before they have like, you know how we have like the trash can lids that have a smaller hole? Okay, because before that they were just regular trash can lids, so not only would students feed the squirrels, but the squirrels could easily get into the trash cans. So basically what happens when you're doing that is that the squirrel population becomes very friendly and it becomes overpopulated because their food source has increased. So you think about like those population studies and you think about what happens in a tube, right? Like the population is going to be controlled during that stationary phase because you're not getting like extra food in the situation. When you add extra food into the population grows. So now we had an overpopulation of squirrels at COC combined with the fact that the squirrels are really friendly. Like, I don't know if anybody's been to CSUN and lately, like the squirrels will literally like crawl right up your leg as you're sitting there and try to eat your food. Why do they do that? Because nice students feed the squirrels, right? So now the squirrels think like, oh, people, this is where I get food. So it increases the population. It also makes them really, you know, infringe on the human population, which is not a good thing. It's not a good thing at all, because then you end up with like what happened here was that the health department came, then they started investigating because they saw that we had a lot of squirrels, and the next thing you know, we had to have a squirrel eradication. And that made everybody upset, because like, who wants to think about just having to kill a whole bunch of squirrels? So it was just like a big thing if you lived in the community or you were here. It was, I don't know. I don't know. Because it's been like that forever and it's really bad. I know it's really bad. Pardon?
So maybe there's squirrels on the family.
I don't know. Yeah, I don't know. I don't know if it's like less rural there, if they have less, I don't know. I have no idea why they never were forced to do that. But they were forced to do that here, and it was bad.
Those squirrels are also really, really large. They're
The ones
like
at
little.
CSUN?
They're like large, yeah, and they come literally right up to you.
Yeah.
They're huge.
I know. Like if you're sitting there, they just like come up to your leg, and they just go a little bit farther, and then just literally like will crawl on you. And if you try to shoo it away, they just like keep coming back. Pardon?
Like, hello, squirrel.
So what you guys need to do when those cute little squirrels come up, because my daughter had just told me today that, oh, the other day like a squirrel like was just right there, just like a foot away from her, and it like didn't run away. So I was like, well, when you see that, you have to like make a lot of noise and scare it off. Like you shouldn't let them think that they should be coming so close to people. It's in their best interest to not feed them and let them just stay in a population that is okay for them. Because honestly, it was terrible, because then it was like they had to put poison, and like everybody was upset, and you know, you just think you're doing the right thing by like feeding them because they're so cute. And just like in your neighborhoods, why you don't feed raccoons and possums and things like that. Like raccoons, you don't want an overpopulation of raccoons. They're scary when and they get huge too. It used to be like raccoons were just like cute or something, but now they look like little miniature bears, you know, because people feed them so much and they have so much access to food, but They'll, in our neighborhoods last summer, there was a whole, like three raccoons came into somebody's house through their dog door and like completely like ran up the walls and toppled down a shelf and ran up like a wine rack and like knocked over bottles, and it was just like something right out of the movies. As she was trying to get one out, another one was coming back in, and they're like really mean. They come up to our window and you try to scare them away and they just like stare at you. You know? Like you guys know what I'm talking about, right?
I've never seen it.
They come up and they're like this big, and then I have 3 dogs, so the dogs are just like going crazy, and the dogs are like this far away from them, but there's this, sliding glass window. They're not even remotely startled. You know, they just like sit there like, you can't do anything because you're behind that, They're scary. So there's a lot of things about Yersinia pestis. You think there's going to be something on the test about Yersinia pestis? It is something that you should be aware of. You should be educated about, and that you know that behind the scenes all these kinds of things are going on that like are protecting the public. So anything that you have to contribute, Emil, from your paper?
No, you covered it. The thing I was going to add was that you mentioned it towards the beginning already, was the handling of the dead ones, because that's another one that people don't realize that's how it's passed on, because they think it's just fleas, and it also goes to our dogs.
Yes.
So, but you already covered that.
Right, the cases that are most likely that the dog picks it up, but I think I never got to the point that then the flea gets from the dog onto you, because right, you're like petting your dog and it crawls on you. Those particular fleas would rather not be on a dog or a person. They would prefer to be on the rodents. So it's when they die off. Just because like different insects like that, they like different temperatures. So they prefer the proper temperature, which is like the temperature that it is like on the rodents. So it's not perfect on a dog nor a human. There's a kind of a picture like when you wonder about bubonic plague and the inflammation of the buboes, in the lymph nodes. Really, really gross and supposedly extremely painful. And you think too, you wrote something about that too, how they used to take the dead bodies and or did you not? Somebody else, like Sean's not here today. But that was one of the things that they used to do in these warring areas. They would take like the plague bodies and like throw them over into people's areas. Pass it on. You never heard about that kind of stuff. So you see your high mortality if untreated, but it is treatable. It's just going to be less treatable when it gets to the pneumonic plague. There's another one in here, Haemophilus influenza. I'm not going to add this to your list, but this is another cause of meningitis. When this says meningitis in children, just because specifically if you were to get Haemophilus influenza, you probably just have something that was like a bad cold or flu, not likely to be meningitis. And this one, they do vaccinate for it. Now in here we have a few more to go, and it's going to be this one is our next one. Delovibrio. Delovibrio is one of those organisms that actually is predatory against bacteria. So I think like if you guys have been doing anything on the Course Smart, I left like a little thing that talks about the life cycle of Delovibrio. I'm not going to ask you to go into detail like that, but it is kind of interesting to see what happens. You see here, collides with prey, bores a hole through the cell wall, and disrupts the cell membrane. So basically this is a bacteria that will then attack another bacterium and kill it. Here it says resembles bacteriophages, so it's kind of similar in the fact that it goes into the cell. And they are working on using an organism like this, as a type of antibiotic. If you can use something that will kill off, that is not going to be any type of substance that the bacterium can produce some kind of resistance to. So, Delovibrio. And there are others that are similar to that, but it's a predatory bacteria. Pardon?
So what's the difference between that and a bacteriophage?
A bacteriophage is just a virus.
Oh,
I mean, that's the main difference. And in a bacteriophage, it's like producing more bacteriophages rather than just killing it off. But it's interesting. Watch that little, I mean, you don't even have to go on the course or anything, but if you just go on the website for the book, there's just a little animation on there that shows that. Okay, and this next one in here is going to be myxobacteria. Myxobacteria, remember there was that other slide and the one before that talked about the gliding movement. Myxobacteria is one that glides on surfaces. It also forms a fruiting body. It looks like a slime mold. So even though I didn't make you have to learn things about slime molds, we did look at the pictures of the slime molds. They're really interesting to look at. And this one, if you look at it, it's very similar. It forms these type of fruiting bodies. And this used to be in its own category, and they were the gliding fruiting bacteria. Gliding fruiting bacteria. So they form these fruiting bodies, and they form myxospores. Myxospores are going to be another type of resistant structure. So again, when you talk about diversity, here's another example of the type of diversity. Myxobacteria. Let me go back here. Myxobacteria. This is a group. They form fruiting bodies. They have a gliding movement. They form myxobacteria. Myxospores. And you see here, I think I mentioned before about like the slime trail that those gliding bacteria will leave. All that slime like that looks like what happens like when you have a whole bunch of snails. All that slime trail is from those myxobacteria. Just moving along slimily on that. And now the last two examples in this group. Campylobacter. And really I would say Campylobacter jejuni. Campylobacter, you probably, how many people have heard of Campylobacter? Why have you heard of it? Just read about it or something? Because this is actually considered to be the most common foodborne infection. So it's really, really common, but it's not something that very many people have heard of. Campylobacter jejuni, though, is something that is, again, the fecal oral route. It's carried by birds. So it really is like even in bird guano. So then birds like flying around and like bird guano, you can even like have a contamination from something like that. What's really, really significant besides the fact that it is considered to be the most common foodborne infection is that this is a low dose organism. So that might be in here someplace. Let's see. If it's not low dose, really important. What's so important about a low dose organism is that you don't need to have a big exposure in order to get sick. That probably explains why it's more common. And you don't have to have the same amount of food mishandling in order to get sick from something, because normally in a higher dose organism, you have some kind of exposure to whatever the food is, then the food sits there for a period of time, so those organisms grow and grow and grow, and then they get into that, infective dose. With Campylobacter, you don't have to have that time in there. Something can just be contaminated, and you can just pick it up. So a low dose organism makes it really very significant. Let's see, but I know I looked up something about Campylobacter more recently. It was, where did I write? I think what it was that Campylobacter, yes, now I remember. Campylobacter, and I know I wrote it down some places. Yes. Campylobacter rates are up 14%. It just came out this month, April 19th. But what I was going to add in there, that the two things that went up the most is the Vibrio parahemolyticus. Remember Vibrio, Vibrio cholera was the one that I said that you had to know, but I was saying that there are several other ones, several other Vibrios that really are the ones that are more common here in the U.S., associated with what? Raw shellfish, like raw oysters. Vibrio parahemolyticus is up 43% in raw shellfish. Okay, that's in the U.S. I just thought I'd add that because it just came out on the 19th of this month. Pardon? No, but you want to know, right? That's one of the ones you don't have to know that, but you want to know that because we had that discussion about eating raw oysters. So just because it's up 43%, I don't know if that would affect how you feel the next time you go and read that warning label. Up 43%, that's a lot, right? I thought you'd want to know that. But anyway, Campylobacter is up also for some reason. They don't know exactly why, but one of the reasons they think it might be is, you see that it's not just in chickens, turkey, and cattle and stuff, but it could be in any kind of raw meat because it's a fecal organism. But they think that there could be an increase because of like all the ground turkey and ground chicken that people use now, because that's much more common now than it was before. A lot of people are switching from like ground beef to ground chicken and poultry. But it could be in ground beef as well. So I don't even know if that like really helps explain it or not. Anything that's ground though, that's always an issue, right? You remember the things that we talked about last time. You're increasing surface area. You're taking like a little bit of exposure and passing that through everything, because every piece of ground meat touched something, right? Or ground poultry. Like you can't grind it without it having touching a blade. There's just an increase in handling of that. So this is something, if you look here, it also secretes a toxin, inflammation, ulceration, and bloody stools. Not something that you want to get. And prevention is just safe food handling, good personal hygiene. Anything that's the fecal oral route, it's just a concern because it's very hard to control. Yes.
So it's invasive also.
Pardon?
It's invasive also, so it's
Yes. And then lastly in this category is Helicobacter. Helicobacter pylori. I'm sure that you guys have heard about this organism before because this is the organism that they feel is responsible for the types of ulcers that people get. It was for so long that people were thought to get ulcers because they were worried, because they had a lot of stress. Even though like stress and worry, they know changes your immune system, and maybe that produced extra stomach acids, and then those acids then were destructive against, different parts of the gastrointestinal system. But now they know that the majority of these types of ulcers are caused by this particular organism. There's a lot that isn't really known about this organism, though, because it's something that they find that a lot of people have it, but not everybody has an ulcer. So they're not really sure exactly how people get it, or why some people get it and have a problem with it and other people don't. But people that have ulcers have been able to be treated with antibiotics and had it, really make their symptoms like start declining. So there's still a lot that's not known about it. Also, it says here carcinogen is simply because it has been associated with, people having this infection and ulcers and then leading to like stomach cancers and such. Let's see if there's anything else. So see here, you see transmission probably person to person, but they don't really know. Like you see differing reports now, there's different theories, but it really, at this point, it's not really 100% sure what, how people actually get it, how it ends up that in the same family, you don't necessarily see people getting it, even though it could be person to person. So any questions about the ones that we talked about today? What can we get? I'm sure we can get it. So now this one, the low G plus C, the next one, chapter 22, is the high G plus C. I'm not expecting you to remember where every one of these organisms comes from now, as far as the chapter goes. I'm just not going to ask you that. I'm just going to be happy if you know the organisms, you know the groups that we talked about, and you know what they're associated with, but not what chapters they came from. Okay, here's one that you already know something about, the mycoplasmas. So the mycoplasmas is a group, okay, a group. What's unique about the mycoplasmas is that they don't have a cell wall. So when we talked about the cell wall in the bacterial cell, chapter 3, we mentioned the mycoplasmas. That's a whole group of bacteria that don't have a cell wall. They don't have a cell wall, which makes them be pleomorphic. So they're very irregular shape. So no cell walls. They're pleomorphic. They have a smaller amount of genetic information. So you see this genome, less than 1,000 genes. One of the smallest found in the prokaryotes. One of the smallest bacteria. They form these fried egg colonies, they're called. Because if you look at them, they look like little fried eggs. Okay, so as a group, no cell wall, pleomorphic, small genome. The organisms themselves are small, and they form those characteristic fried egg colonies. And it does seem like it's just one of those really unique groups, but it does turn out that there are mycoplasmas like Mycoplasma pneumoniae that is a very important cause of pneumonia. So I'm just going to ask you to know about mycoplasmas as a group. I'm not gonna put Mycoplasma pneumoniae in there, but it's the most common cause of that walking pneumonia. So you see here, primary atypical pneumonia, walking pneumonia. So you've heard of people that they're sick, they're coughing for a few weeks. They go to the doctor and then they come back and they say like, oh, I have walking pneumonia. They're not like sick, they're not hospitalized, or not that they're not sick, but I mean they're not like seriously ill to be hospitalized, but they're just like hanging on with this persistent cough and some symptoms of pneumonia. So there are other, pathogenic species also. Okay, and now we have a bunch of important examples in here. So I'll give you a couple of these. Clostridium botulinum. Okay, so of these, we're going to talk about, and this is going to be on your list, Clostridium botulinum, Clostridium tetani, Clostridium perfringens, Clostridium difficile. So this is a genus that has a lot of examples that are really, really important examples. Clostridium botulinum, the cause of botulism. Okay, there are different types of botulism, but mostly you think of botulism as being a foodborne illness. Basically, it is a food poisoning because the organism grows in an anaerobic environment, like a can, and then produces a toxin, and somebody ingests that toxin. And if somebody ingests the toxin and is not treated right away, then really what happens, the person ends up paralyzed. So first starts with symptoms like slurred speech, blurred vision, and by the time it really gets to that point, it's very hard to reverse any of that damage. Because of the fears of botulism, when we can foods here in the U.S., we've really only had one outbreak in the past 50 years where they found botulism in something. Because we overheat, we just heat and heat and heat cans to make sure that every last, oh, and by the way, this is a spore-forming organism. Spore-forming. All of the Clostridia here, remember we use Clostridium sporogenes? So just remember, all the Clostridia form spores. So basically, we cook and cook and cook and cook the cans. So if you remember something about the log death, like killing off organisms, or the organisms dying off in the growth curve, like that was the opposite of how they grew in the growth part, the log growth versus log death. When you kill off organisms, they have to be killed off in a way in which they realize that you can't kill off all of them in any one time frame. So it kind of sounds confusing a little bit, but basically what they have figured out is that if you're treating them, and this goes especially with heat, but it actually is applied to a lot of other things too, like even using disinfectants and antiseptics, that say they find out in 10 minutes that you can kill off 90% of the organisms. So that means in the next 10-minute time, you still can only kill off 90% of the organisms. And then in the next 10-minute time, you can still kill off only 90% of what's left, and so on. So each one of those is called a D value. Each one of those, or decimal reduction time. Each one of those decimal reduction times kills off 90%. So for example, if you had 1,000 organisms, and this is something that we're actually going to refer to again, so it is kind of information that I'm not likely to ask you about the D values for this test, but I will for the next test, for the final. But, or maybe it will be on this test. Never mind, it will be on this test, but it'll be associated with the control stuff. if you kill off, say, 1 million organisms in the first 10 minutes, you have killed off 900,000, but you have 100,000 left. In the next 10 minutes, you kill off 90,000, but you have 10,000 left. In the next 10 minutes, you kill off 9,000, but you have 1,000 left. In the next 10 minutes, you kill off 900, and you have 100 left. 10 more minutes, you kill off 90, and you have 10 left. Then you kill off 9, and you have 1 left. Then you kill off 0.9, and you have 0.1 left. That's considered dead. That was 7 D periods. Okay, so in the control, like when you learn about controlling microorganisms, 7 D values would be considered dead. Okay, and this is something that is based on what's called Chick's law, like chick, like a little chicken. Chick's law. When you hear about anything in sciences that's a law, what does that mean? It's not a theory anymore. This is something that has been proven over and over. You cannot kill 100% off in any one period like that. So 7 D values. In the food industry, they use 12 D values on canned foods. 12. So they just keep on with another, whatever the D value is. The D value can change depending on what the conditions are. Like if something is just in water, it's going to have 1 D value. But if that same food is with milk, it's going to have a D value that is much bigger. And if that same food is in milk and sugar, then the D value is even longer. So they have to figure out what the D values are and then make sure that they go to 12. That's why we don't have problems with botulism. Botulism most often occurs in a situation like home canned foods, right? Which, if you grew up in Southern California, you probably barely know what home canned foods are, right? But if you were like from the Midwest or the East or Europe or whatever, it wasn't uncommon for people to gather up whatever the crops are at that time, or like the fruit trees or whatever, and then can your own things. That's where they put them in those mason jars with those lids on them. Maybe you know about jams and jellies, which don't have to go through that many D values, by the way, because they're so sweet and they're full of sugar, so you don't have the same concerns. But things like when they can tomatoes, green beans, corn, and stuff like that. So basically, if people home can foods, and especially if they're not acidic foods, they have to make sure that they use a pressure cooker. Okay, because otherwise you won't kill off all the spores. And then as it's sitting on the shelf in the basement, because where people do a lot of canning, they usually have basements, and then they would, it was cool in the basement, they would leave, you know, shelves that had all of these canned, you know, even though they're in glass. And then when Christmas time came, if you had relatives that lived there, they would send you those home canned things, right? Nobody's experienced any of this, right? You're all like, what is home canned foods? I know some of you guys must know. If you do have one of those people that does that, all you have to do is boil the food for 15 minutes, and it will destroy the botulism toxin. Okay, boil it for 15 minutes. Most people don't boil their food for 15 minutes. If you were heating up, you know, a can of food, you don't boil like the green beans for 15 minutes. Maybe you bring them to boiling, but you don't boil it for 15 minutes. But if you did, that would kill off, or not kill off, but that would destroy the toxin, just because of that toxin. So really, that's where the cases of botulism tend to come from in the U.S. and other inadvertent things. What you need is a spore that hasn't been killed off, put into an anaerobic condition. Okay, where are the spores found? In the soil. The organism is in the soil. So you grow your green beans in soil, you're rinsing them off or whatever, but spores are still on there. If you don't use a pressure cooker, because a pressure cooker would be like autoclaving, so you will be able to